Good morning, afternoon, or evening. Okay, so what I'm going to do today in math is I've had a fair number of questions dealing with the mid-chapter review and the probability odds section. So I'm just going to go through those ones that I assigned, walk through them. I know there's answers in the back, but I'm going to walk through the techniques or the solution that you use for each of them today. And I'm going to break that into a few different videos, maybe 2 questions a video, so that it doesn't take in case don't have to watch them all, excuse me. And that's what we're going to do. So the first one is number 2 on page 327, and that talks about sample space. So it's right in the very beginnings of the probability. So it's just talking about finding the number of outcomes based on what they give you for sample space, and then identifying which one of them are the favorable outcomes. So for example, when this would be exactly the same as doing a 2-sided dice one, except in this case you have 2 spinners, one that goes from 1 to 4 and one that goes from 1 to 5. So the first step, as soon as our blackboard pops open here, is to get your sample space drawn. So that would be making your 5-sided spinner on one edge, and on the other edge making your 4-sided spinner as well. Except my old computer is taking forever to boot up here. For some reason, this thing is just a piece of junk. It takes so long to boot everything in. So we'll give it a chance here. There it is. Okay, so finally. Okay, so we'll just go through each of these as we're going. Again, if you did well on them, that's fine. But as I said, I had a fair number of questions, and being stuck here in Vanguard, I can't really come out and see everybody right now. So we'll just go through them as best we can here. Okay, so the first one, let's make that sample space up. Okay, so if I make my spinner 1, 2, 3, and 4 here, okay, that's the top die. Then I'm going to go 1, 2, 3, 4, and a 5 because, oh, what the, come on. Now, oh, look at this. Now it's stuck on that. What are you doing? This old computer is so bad. Okay, let's give it another try. Okay. Okay, so let's get back on here. Sorry about that. Okay, so we got the 1, 2, 3, and 4 for the first die. Like that. And then we do 5 down here. 1, 2, 3, 4, and 5 down here like this. So that gives us a 20 space sample. Okay, the blue numbers are the spinners. Now the sample is going to only be these squares inside, so I'll change colors here so that they're different. And these will be our totals here. Okay, 2, 3, 4, and 5. 3, 4, 5, and 6. 4, 5, 6, and 7. 5, 6, 7, and 8. And the last one here, 6, 7, 8, and 9. So that's our total sample space. And then the questions that they ask is create the sample space. So there's the sample space. These are all the possibilities in red here. Okay, then it says determine the probability that for each die, the sum is 5. Okay, player loses trick. The sum is 5. So we got to look here for, let's change to green here for answers. Sum of 5 would be 1, 2, 3, 4. So that would be 4 favorable over 20 total. That's probability. That reduces down to 1 over 5. Okay, and that's our first probability. 2, the sum of 8 or 9. So 8 or 9, if we do 8 or 9, okay, so 8 or 9, there's a 9, there's an 8, there's an 8. So that's 3 favorables. So that would be 3 over 20. Cannot reduce that one. Okay, if they do decimals, okay, if they did a decimal point, 1 over 5 would have been 0.2, and 3 over 20, that would have been 0.15. Okay, and the last one that they ask you, if the sum is 4, the player moves back. So the sum of 4 are these 3 4s here. Okay, it's kind of the same thing as these ones here. So okay, if you did percentage, it would be 20%, 15%, 15%. Okay, so that was the first one. That was number 2. Okay, and that's 327 that we're looking at, the mid-chapter review. Okay, let's do number 3. The second section deals with odds and probability. So I'm going to move this up now. Okay, so if you're looking at number 3, which I'll go back into here. Okay, so number 3 says, Fatima draws a card at random from a standard deck of 52. Determine. Okay, so we're looking at probability. So probability is favorable events over total. Okay, it's favorable over total. Okay, odds for are favorable versus the unfavorable. Okay, and odds against, that's unfavorable versus favorable. Okay, and remember that the total always equals the unfavorable plus the favorable outcomes. Okay, so those are the things that you have to remember for probability. Okay, so it's determine the probability of the card being black. So we know that there are 26 black cards and there are 52 cards total. So that's going to give us 1/2, which equals 0.5 or 50%. Okay, determine the odds in favor of a card being black. Okay, so we have in B, we have 26 black and 26 not black, or red if you like. So we got this is favorable, this is unfavorable. So the odds in favor are 26 to 26. So if you reduce that, that's 1 to 1. Okay, so odds are different. Determine the odds against the card being a diamond. Okay, so odds against. So diamonds, there are 13 diamonds, okay, in a deck of cards. Not diamonds, okay, so there's 39. Or if you want to do suits, you can go 1 suit of diamonds and 4 other suits because it's going to reduce down. So it says the odds against. So odds against is not non-favorable over favorable. So 39 to 13, which if you reduce that down, it's 3 to 4. Odds against. Okay. Last one, determine the probability the card is not being a face card. Probability of not being a face card. So this one has to be over a total. So we'll move this down. Okay, number D, or letter D, not a face card. Probability of not a face card. Okay, so that's what we're going to do. So we have to determine how many face cards are there in the deck and what are the total. So number of face cards in a deck, there are 12 face cards. And there are 52 total. So we don't have to find unfavorable and favorable because it's probability. We have favorable and total, so we're good. So the probability of finding a face card, of not finding a face card, sorry. Okay, so, okay, not getting a face card. Okay, well, what's 52 minus 12? 52 minus 12 gives us 40 not face cards. So we got 40 non-face cards. So that's 40 over 52. Okay. If we divide that by 8, I think, it should reduce down. Let's see here. No, just 4. 10 over 13. Okay, if you want that as a decimal, that's 0.77, 0.77. Okay, and that was the first two. This is number 3 here. First one was number 2. This was number 3. Okay, and that one dealt with probability. Okay, I guess we'll do number 4 as well here because it's still in the probability one. And we're only 12 minutes in, so keep on going. Okay, so that's the kind of how you read and look those ones up. So let's skip ahead here. Either the fourth one. Come on, this thing's going to shut down on me again. It's not advanced. Look at this. I hate my computer. Okay, I might not be able to save the notes here because it's giving me so you can see it's not letting me go ahead, so I'm going to have to shut her down. Okay, so hopefully you can take your own notes on video there. We'll just boot her up again. Sorry, guys, technical problems this morning. Okay, so let's start with number 4. Number 4 is also going to be a probability odds question. A junior golfer enters a tournament. According to his recent performance against the other players, the odds against him winning, okay, so it's giving you odds, are 23 to 5. Determine the probability that he will win. Okay, so when you're doing these ones, when you get odds, remember that the total is the sum of both the numbers given. Okay, so that's the key there. Okay, so this one is going to be number 5. Oh, sorry, 4. Okay, so the key is when you're dealing with odds, the sum of the two numbers gives you the total outcomes. Which is always what goes on the bottom of probability. Okay, so if we talk about this junior golfer here now, his odds against, let me just skinny this up because I don't like it being fat like that. So odds against are 23 to 5. So this is unfavorable and this is favorable. So the total outcomes would be 23 plus 5, which would be 28. So that's going to be what goes on the bottom of probability. Okay, so that it says, determine the probability that he will win the tournament. So probability of winning is favorable outcome over total. So the favorable one is the 5, and the total is the 28. 5 over 28. Okay, if you want that as a decimal, 5 divided by 28, that gives you 0.179, or 17.9%. Okay, so that would be number 4. Okay, so the key there is whenever you're dealing with odds for and against, it's whichever one comes first. Against is unfavorable first, odds in favor or for, favorable first. And the two numbers always add up to the total. Okay, and then as Seth mentioned yesterday here when we were doing this in Vanguard, number 5, the stupidest possible questions he's ever heard in math, I think was your direct quote. Okay, about the prime ministers. And it is kind of confusing because of the wording. So we'll look at number 5 next. And that one deals with odds for and against, but they kind of read a bunch of weird stuff into it. I guess I don't know why they do that, but it's the way it is. So let's see if this goes to the next page. Oh, it worked! Amazing. Okay, so this is number 5. We'll just keep going on this video because we're only 17 minutes in. Okay, so in a group of 22 people chosen at random, the probability that 2 people are having the same birthday is slightly less than 50%. As of 2010, Canada's had 22 prime ministers. Determine the odds in favor of 2 of our prime ministers having the same birthday. Okay, so they're giving you probability. So when you're talking about percent, the total is always out of 100. So therefore, 50% means 50 favorable out of 100 total. That's what it means, because they gave it to you as a probability. And what they're saying is the probability of having the same birthday for 22 people. 22 has nothing to do with this other than it's giving you the same sample size. Okay? So then it says, determine the odds in favor. So odds in favor or favorable equals the favorable outcomes to the unfavorable outcomes. Now, we don't know the unfavorable outcomes because the favorable outcomes is 50% and the total is 100. So we have to figure it out. So remember that 100, the total, minus the favorable, which is 50, equals the unfavorable, which is 50. So we know that the unfavorable is 50. So unfavorable equals 50. Favorable equals 50. So the odds in favor are going to be equal to 50 to 50. If we reduce that, that's 1 to 1. Okay. The second question is determine the odds against 2 of our prime minister. Now they kind of got another assignment. I'll have to get that right away. It's the opposite of this. Odds against. Now they say slightly less than because they put that word in there, so you can say that as well. But the odds against are going to be unfavorable to favorable, which turns out to be the same thing. 50 to 50, because you're flipping two of the numbers around that are the same. It's 1 to 1. Then, of course, they throw in the research thing. You don't have to do that, but if you want to. Seth, did you do that? He says no, he didn't bother. Okay. Okay, so that's number 5 in there. Okay, then we get into the last part talking about some more probabilities using cards and things like that. So let's go through those. Again, we're only 20 minutes in, so we can still use the same video here. And now the button's working down here. So I can go to the next page. Okay, so number 6 and number 7 are the last two. Okay, number 6. Okay, these are 3 people are randomly chosen from a fellowship of 14 people to be president, treasurer, and secretary. What is the probability that Frodo, Sam, and Aragorn will be the chosen? Okay, so this is a permutation question. How do I know it's a permutation question? Because you're choosing 3 people from 14, and each of those 3 people have a specific job to do or a specific order. So the first thing you know is that order matters. Therefore, you're going to be using permutations. Now, there's a couple of different ways we can do this one, of course. You could kind of figure it out by counting it through. With permutations will work if you use the blanks, but you can also use the permutation formula. So they're asking for finding the probability. So when we're finding probability, we have to have total outcomes and favorable outcomes. So the total outcomes possible have to be figured out first. So the total outcomes possible, you ask yourself, how many ways can I pick 3 people from 14? So that means picking 3 people from 14 with specific jobs. With order mattering. Okay, so that means we're going to do a permutation. So you could do 14p3. Okay, so if you do 14p3, okay, 14p3, if I do that on the calculator from here, you get 2,184. Okay, alternatively, you could have done the counting principle. The counting principle works with permutations. It does not work with combinations all the time. So you have to be careful. Okay, so you could have done 14, not 14, 13, and 12, which would give you the same thing. Okay. I usually do this permutation way. So this is total number of outcomes. Okay, now the favorable number of outcomes, they have to think about it. Okay, it's saying 3 people are chosen random, and then we want to get 3 people to be in 3 positions. Okay, so we could do blanks or permutations again. So how many ways can you organize Frodo, Sam, and Aragorn into president, treasurer, and secretary? Okay, so obviously there's going to be 6 ways because you think about it as a 3 factorial. So the favorable outcomes, how many ways can 3 people take 3 positions? Okay, if you want to stick with permutations, it's still permutations because order matters. It matters if you're the secretary, treasurer, or president. So you're basically doing 3p3. So 3p3 is 3 factorial over 3 minus 3 factorial, which is 3 factorial over 0 factorial, which is the same thing as 3 factorial, because 0 factorial is 1, which equals 3, 2, 1, which equals 6 ways. So now you have your favorable and your total. So the probability of this occurring is going to be 6 over 2,184. Okay, so what's that going to reduce to? 6 divided by 2,184. That's 1 over 364. Okay, if you as a decimal, that's decimal 0027. And I don't know if the back used a fraction or a decimal. What did it use? Did you guys check?
Mostly decimal.
Okay, yeah. Okay, the back used both actually, so it worked out good. Okay, that's about 26 minutes. So the last one, this is the one about Euchre. So this one has cases in it, and it is challenging. Okay. All right, so let's go through the last one. All right. Euchre is played with a deck of 24 cards. So the first thing we know is that there's a sample space of 24 cards. So total outcomes equals 24 cards. Well, I guess it's not 24 because we're taking 5 out of there. Our total cards, we'll say. So we don't get confused because total outcomes could be different depending on if we're talking about hands or cards. So we'll say the total cards are 24. All right, so this gets a little bit challenging. Okay, so then it says they have a 9, 10, Jack, Queen, King, and an Ace. Okay, 9, 10, Jack, Queen, King, and an Ace. So that's 6 cards per suit. Then it says each player is dealt 5 cards. Determine the probability that a dealt hand will contain the following. So we're dealing hands. So when you're dealing hands, order that you get the card doesn't matter, because if you get it first or fifth, you still have it in your hand. So this deals with combinations, because order does not matter. Okay? Now, this is where it gets a little interesting. Okay, each player dealt out. So what is the probability? Determine the probability that you'll be dealt a hand containing the following: an ace, king, queen, jack of the same suit. So we have to find the total number of possible hands first. So the total number of possible hands in the game. Okay, how many 5-card hands can be dealt out of 24 cards? So that's 24C, 24C5. Okay, so I'm just going to do that one on the calculator. 24C5 is 42,504. So this is the total number of possible hands you can get. All the combinations together of what different combinations of cards. So now you have to find the favorable. Now there's a couple different ways to do this. Okay, you want to get ace, king, queen, jack of the same suit, but you have 5 cards. So let's talk, you could have diamonds, hearts, clubs, and spades. So there's 4 hands, four possible suits to look at. Okay, so if you look at each suit hand, okay, so let's say you get the ace, you get the king, you get the queen, you get the jack. Okay, how many cards are left in the deck if you've taken out the ace, queen, king, and jack? Well, total number of cards is 24, so there's 20. So there are 20 ways to get one suit of ace, king, queen, jack, plus a card. Because you have to have another card, right? But if there's 20 ways to do that for one suit, there are how many suits? There are 4. So you're going to do this 4 times. Okay, or you could just multiply it by 4 because it's going to be the same. Okay, this is hearts, diamonds, spades, and clubs. So there's all your possibilities. So how many possibilities total do you have? There's 20 ways you can get hearts. There's 20 ways you can get diamonds. These are all ors. So you add them. 20 plus 20 plus 20 plus 20. Now, or sometimes you could just say 4 there for 4 different suits, right? So you get 80 ways. Okay, so there's 80 favorable ways. So your probability is going to be 80 over this big number here. Okay, so that would be 80 over 4. We'll put the probability up here. Probability of the hand is going to equal 80 over 42,504, which can reduce, I think. Okay, so did they give it as, let's see, did they give it as a decimal or a, oh, they just leave it as 80 over 4. They don't reduce it. But if you reduce it, it's 10 over 5,313. Which if you do a decimal, it's 0.00188. Okay, so that's the first one. All right, so that was A. Okay, now that one wasn't too difficult if you just think about how the cards are dealt. But it could be a little bit challenging for sure. B is how many ways can you get 5 cards of the same color? Well, how many colors are there in the deck? 2. So you're going to have 2 possible hands. So your bottom is going to still be this. Okay, but your favorable for B, you have to find your favorable. Okay, so how many ways can you get the same color? So if we just do, you could do combinations here, right? You have to do combinations because order doesn't matter. So you can't do the blanks per se. But 5 cards of the same color out of how many cards in the deck are going to be red? 12. So we have 12 red and 12 black. So you have 2 cases here. You can get 5 red cards or 5 black cards. So 12 C5 or another 12 C5, right? For getting black and getting red. What's 12C5? I don't know. Let's figure it out. 12C5 is 792. Okay, if we're doing the OR, do you multiply or add? You add them because you can't have red cards and black cards. You can't have all red cards and all black cards, but you can have all red cards or all black cards. So we add them because they're OR. So 792 plus 792 is 1584. So our favorable equals 1584. Okay, so then if we do the probability of all of one color, it's going to be 1584 over the same number that we had before, which was what? 42,001. Anybody remember? 42,504. Okay, which can be reduced again. What does it reduce down to in the back here? So they just leave it. They don't even reduce it. They leave it like that, but it should be reduced. Okay, so as a decimal, what is that? Whoops, I multiplied it, sorry. 1584 divided by 42,504. 6 over 166. Or if you're doing a decimal 0372 or 3. Okay, the last one. All 4 of a kind. 4 cards of the same rank. Okay, so this one has lots of cases. You can have 4 aces, 4 kings, 4 queens, 4 jacks, 4 tens, or 4 nines. So we have 6 possible ways to get 4 of the same kind. So if we think about it, for one hand, let's do one hand. We could do a permutation again. Okay, so if we want all the aces, for example, there's 1 ace, 1 ace, 1 ace, 1 ace. Now this works for aces when it's all 1 aces. And then again, there are 20 cards left in the deck. But we have to multiply this by 6 because there are 6 different 4 of a kinds. Okay, so that's one way to do it. Or you could just draw it all out, or you could do, permutation. How many ways you pick this one, this one, this one, and this one? But our combination, pardon me. You could do all the combinations through here if you like. So this is going to be 20 times 6, which equals 120 favorable ways. So then you get the 120 over the same 42,504. Okay, and again, I don't know if they'll reduce it. Nope, they didn't reduce it. But if they did reduce it, it would be 5 over 1771, which would be, as a decimal 00282. Okay, so that's me walking through that, and I'm going to post this on the main page because there was more than one person that was asking me about some of those. Okay, sorry about the thing crashing on us, so I'm going to just post the video part, and you can kind of watch it through and work it through, and hopefully this will help you get through there. One thing I can promise you is that we'll do some good studying for this unit at the end with probability. And I do focus on somewhat simpler type questions, the basic type questions. And we'll go through that when we get near the end and closer to that. But I'm going to stop the video there because we pretty much did a whole 40 minutes on that. Hopefully this will help you.